Hello, everybody, and welcome. Thank you for joining us today as we discuss CPM scheduling. This is a four-part series that we've put together that's going to, teach you a little bit about what is CPM scheduling, where did it come from, why is it useful? That's what we'll be discussing today, and get us through building a high-quality baseline, schedule updating best practices, as well as getting into some schedule analytics over the next 4 weeks. Right now, let's give it a couple minutes for more people to join, and I'll get started in a couple minutes. Just want to make sure you can hear me. If anybody can respond and tell me that you can hear me, that would be helpful. Excellent. Looks like you can definitely hear me. All right, well, let's get started. Again, thank you for joining us today. This is the first part of a four-part webinar series on CPM scheduling in construction. Who am I? My name is Michael Pink. My name is Michael Pink. I'm the founder and CEO of SmartPM Technologies. We are a schedule analytics platform and project controls automation platform for the construction industry. This is a business that I had started several years ago after I'd been a consultant at companies like Deloitte, KPMG, FTI. I was a construction schedule and delay consultant, and I had spent 20 years doing that. So I had spent my fair share of time looking at schedule data, understanding projects from beginning to end, impacts, delays. Lots of times we got involved on the front end to put together good schedules. Lots of times we got involved throughout looking at progress and performance, studying schedule updates, and quite frequently we got involved doing full forensic analyses on projects that had taken too long and maybe had gotten into a situation where there was discussions over delays and overruns. So in that time, I've had a lot of experience looking at schedules. I've learned a lot through that. I'm a certified PSP, planning and scheduling professional, and certified cost engineer through the I'm an industrial engineer, which is essentially a process improvement and optimization and efficiency major, and I have an MBA. So yes, we started SmartPM Technologies with one goal in mind, and that's to help the construction industry perform better, get projects done on time, on budget, and keep out of court. One of my biggest theses is that the schedule data is the most rich data in construction to be able to do that, which is why we built out a technology that helps you study that schedule data and make sense of it in terms of performance and risk and in quality and integrity of information. But that's really what our business is all about, and that is why we offer this course. This course, as I mentioned, is a four-part course. Today's a little bit, I would say, straightforward and as an entry-level type situation where we're just explaining to the group what is CPM scheduling. It was interesting to me as I got out in the market working with various customers that there's a lot of people who don't actually understand what the CPM scheduling programs are all about. Lots of times people think it's just about putting activities on a page over a calendar and managing to it. They don't understand completely where did this process come from, why is it useful, how do we get the most out of this process. We're going to be talking about that today. So that's really for our less experienced people. We teach this course with a lot of different customers. Sometimes we're working with project managers, we're working with superintendents that have never even turned on a scheduling program. So we have to start somewhere And the foundation of it all is understanding what is this program all about? What is CPM scheduling? Why has it been embraced in the industry? Why is it of use? And why are we actually doing it? And what do we get out of it? So that's what we'll be talking about today. Next week, after I explain a little bit about why would we do such a thing in construction, we'll start to talk about a methodology that ensures that you're building schedules that are worthy of managing a job. You know, it's interesting. We've studied, 20,000 plus schedules across the industry over the last couple of years, and we see that 80% or more are of medium to high risk of being useful, meaning that they're not built using best practices. And most of that's because not everybody understands the best practices. And a lot of people believe they can use the program and, put activities together, string logic together, and then whatever it presents is gospel. But in reality, there is quantitative methodologies to measure quality, and there are best practices that we will discuss next week. Then there's the updating process. So once you have a baseline, it's not over. The schedule is a living, dynamic thing that changes. The whole program requires or is best utilized when you are constantly updating it at different points in time to see what it tells you at that point in time about what's coming up next, what's critical, what activities have high float, what activities have low float, what are some of the risks that happen in those moments that could ultimately derail a schedule or make it, ineffective, which ultimately results in delays and overruns and all those things that we don't like to be a part of in construction. And the last part is, okay, so now I've got the understanding of the schedule of this program. I know how to build a good schedule. I know how to update it well. Well, what do we get out of that transcends just scheduling? Now that gets into analytics, oversight and analytics. What more information can we extract from this very meaningful data set such that we can utilize it to manage effectively? And I think everybody's goal in construction is to get the projects done on time, on budget, and stay out of court. And that just so happens to be why we are in business here, is to help construction companies and owners, as well as insurance companies and consultants, do just that with technology. So let's get after it. So today, basics of CPM scheduling. We're first going to talk about what is CPM and where does it come from? Why did this end up in our industry? What is the method behind this technology? Why is it something that this industry has utilized and embraced? And why does it work? Then we're going to get into some basics about key terminology, because as I mentioned, there's a lot of people on this that may or may not have ever studied this schedule data or know how to build a schedule. I think there's a lot of people on here that do, but there's also a lot of people that don't. So we have to start with the basic building blocks and then work from there to get into ultimately the advanced stuff in 4 weeks when we're talking about analytics. So it's sort of a process to get everybody there. I appreciate you being here. So we'll go over the key terminology, the building blocks, and then I'll talk about what we're going to be doing next week. If you have any questions as we go, we've got a team here that's going to be reviewing some of the questions, and they may interject at certain points to ask a question that may seem very relevant at the time or multiple people are asking. So I'll be trying to answer those as best as I can. If we don't get to that today, we will be following up with answers to all questions via some sort of correspondence after this between now and the next webinar next week. So where did this come from? Where does CPM come from? Well, I have a picture of a pyramid here. And the reason I have a picture of a pyramid is I want to paint the picture that CPM scheduling actually comes from how our brains operate. Even back thousands and thousands of years ago, there was planning and execution of large projects that required more than just throwing a bunch of people at it and saying, go build this thing. There needed to be some sort of structure, some sort of ability to organize in order to efficiently build something and not really waste much time. And if you recall any pictures you've seen of the pyramids being built, you'll see that there was some order in the ways in which these blocks were getting built up and how they were scheduling just via their own minds at the time. But this CPM scheduling technology is really, to me, something that comes with how our brains work. And I can give you another example. If we go, even so far as 100+ years back, before computers were here, you can see that at the time they were even drawing out schedules. They were drawing out schedules the way that these CPM schedules look like in the technology. This is a bar chart. It has a calendar. It has a series of activities that are happening with durations, and that has those activities happening over time, and they've sequenced some sort of order when things can happen. We don't see logic ties, but we do see start and finish dates, which is the math that was going on in the brain and the way in which they were envisioning, how are we going to be building this thing over time? And when this gets done, what can start? And even getting into shading certain critical or longest path items. You can see right here, the darkest line item here is this, what we deem as the longest path, which is what is actually highlighted in these critical path method programs. So even before the technology was available, our brains function when thinking about building a project in a manner that sort of lays it out in order over time with some dependencies, certain things that need to happen before others can. The CPM scheduling program is no different than that. It's essentially taking a process that we do in our brains. When you're thinking about it as a super or as a PM or anybody in construction, when you're looking at those designs, you're thinking about order. You're thinking that I'm not going to be able to put in a foundation until I dig a hole. And once that foundation is in, then I can start laying out each floor. And once those floors start going up, I can start working within those floors. And you really do have it mapped out in your brain of dependencies, but this program is designed to bring that to light for everybody and also give you a little bit more than that. But we'll get into that in a sec. In 1957, this is our first CPM scheduling computer. These scientists came along and they realized that, if we're looking at this stuff that needs to happen in a specific order, and then we go put that order into a computer system and then we update that regularly, what this program can do is start to highlight very important things for us about progress and performance going forward, things that we need to know. Like what path is most critical towards a completion date based on where we are today. That's really was the crux of this program, was listing out all the things that need to happen, listing out all the interrelations amongst the activities, and then having a computer do a lot of math to highlight for you which activities today are most critical for getting, managing to an end date 2 years from now. One of the more interesting parts about that is, as we get into construction and some of these more complex jobs, some people actually believe they can do that all in their brain. I very strongly disagree that somebody at any point in time can walk out to a construction site, look at it, and understand what work today, if delayed, will impact the end date of the job. Because that's very difficult to do. It requires a lot of math, which is why they created this computer to do it. And it worked. It worked so well that somebody came along, Primavera, Microsoft, decided that this algorithm works. And if we make it available to everybody in construction, then ultimately these projects should get done on time and on budget every single time using this methodology that we call CPM scheduling. So that's really the history to me, is that, our brains work a certain way. Projects are very big. Computers should be utilized to be a calculator of sorts to produce a schedule for us that we can manage to. And in that computer program, it's very important that we know one thing, and that is which activities are highly sensitive to delay, such that if they are delayed, they will push the end date out, which is what we all don't want to have happen. We do not want a job being delayed. We want it getting done on time, because time is money, and in construction, time can be a lot of money. So this actually works, this program. If I didn't believe in that, I wouldn't be sitting here trying to explain the nuts and bolts of why it works, how it works, why it came about. I am here to teach you and everybody this program. And I also want to preface it with, there's a lot of things going on in the industry, and it's been going on for decades, where projects are still late and over budget. But to me, this process works if you work it right. So that's really what we're going to learn over the next 4 weeks. So what exactly is CPM scheduling? I've sort of opined on this a little bit, but I'll give you a little bit more information. So CPM scheduling is an algorithm. It's an algorithm and a program that comes with that algorithm that generates a series of activities over time based on, what the user enters into the system, the activity, the relationships amongst other activities. And once you enter that into the program, which is generally in your head anyway, in this program, it could be a little bit more detailed and be a little bit more explanatory of what all things should be happening and when to be as efficient as possible. But what this does is it creates a plan for you based on everything that you enter into it. And more importantly, it gives you a little bit of information, actually a very powerful amount of information, and that is the prioritization of these activities. So first and foremost, they'll show you a priority based on what can and should happen before what. It will also create a calculation, and that's called the float or the slack, that gives you a prioritization plan over what activity today, amongst all activities that are going on today, is the most crucial to getting done on time. And that's really what we start to call our critical path. And we can look at that based on key milestones. We can look at that based on the end date of the job. But really, if you're thinking about just drawing out a schedule and putting it over time and not doing that additional math to understand what that longest / critical path is, what is the most important and second most important activity and third most important activity that's going on today that has the highest risk of delaying the job, then you certainly don't have what you need to make crucial decisions when it comes to anything like resource constraints and whatnot, which I think we all know in construction is a common issue, is maybe not having enough people and knowing which activities have a little bit of room for delay, which activities can be pushed off till a later date versus which activities need to get done today, come hell or high water. So what's the point of it? I ask a lot of people this question when I do our trainings, and I get back some interesting answers, some of which are the point of it is to notify the owner where the project stands, or to use it as a reporting tool, or sometimes to support the payment application process to know where progress is today. Or I've heard this one a lot, is to manage claims, to do a delay analysis. So you have everything documented so you can manage a claim. To me, those aren't the answers. Those are perks. The real answer, the number one reason that this program was created was to assist in the effective management of resources on a project in order to complete the project on time and on budget. The people who invented this process when we saw it in 1957, the people who were drawing those Gantt charts back in 1912, the people who were sitting on the pyramid sites thinking about planning and scheduling, and the people out there today using CPM scheduling and embracing it are all doing it for one thing, and that's to keep a project on track. And that's to manage as effectively as we possibly can to get a project done on time. It's not for claims, it's not for just simply, making the owner happy. This program is designed to manage a job effectively, and it works. It works well. The challenge is most of them are not managed as effectively as possible because not everybody understands best practices. Not everybody understands what risks are associated with, low quality schedules or updates that become too aggressive. So we're going to talk about all of that such that everybody here can walk out of here understanding that this is a meaningful process. It just takes a lot of thought and following a certain set of rules to be managed effectively. So why do we need this in construction? That's a huge question that a lot of people ask, because scheduling, in my opinion, and for somebody who's watched it over the last 20 plus years, there's a lot of debate out there. I've heard people say, I don't need a schedule. I don't want a schedule. This schedule just causes problems. We argue over the schedule. I do the things that it tells me to do, and the project still gets late and over budget. I believe there's reasons for that have to do with quality and best practices. But let's talk real quick so that everybody understands that this is actually useful. Number one is construction is complex. I don't think that there's any industry out there that is more complex than building a construction project or not very many at the very least. If you think about the construction projects that are getting built, first of all, timeframes, a couple of years to build something that costs $50, $100 million, having, hundreds of people on site with materials coming in from all over, using a design that may or may not be fully complete, or things that look good on paper don't actually fit in a three-dimensional world. All these little things that happen, rain, change orders, requests for information, all of these things that are happening all at once, always, and trying to keep to a timeline that's, a couple years away, with tons of materials coming in and out, getting installed, with lots of equipment coming in and out, and lots of people that are scattered throughout a site. To be able to understand that in a bigger way, without just standing there looking around and thinking you know what you know, is challenging. Construction is a very complex thing. Number two is, with all these different moving parts, not everything always goes as planned. When we sit down and we think about what is possible, about, how long should it take to put in concrete, or how long should it take to install drywall or windows across various parts and pieces, or piping, all of those different things, with the weather issues, with the design issues, with the supply chain issues, with the labor shortages, all these little things ultimately result in a series of things that don't happen as things were planned. Mostly because of what's called over-optimism bias, or planning fallacy. We all, when we're asked things like, how long will it take me to do this, or how long will it take me to do that, we all default to, well, what's the quickest I can possibly do it, and let's enter in that duration. So naturally, the construction industry is challenged in that regard, because we are usually thinking, if everything goes well, it'll take 10 days to do this, or 12 days to do that, or 4 days to do this. And in reality, all these risks are happening all along. So all of these things start to take a little bit longer. And then that compounds. So knowing that nothing ever goes as planned, or very few things really ever go as planned in construction, on top of it being complex to begin with, is the reason why we want to use a tool like a CPM scheduling engine. The other thing, delays are costly. When we say we're going to get something done in a certain amount of time, when we prepare those budgets, when we come up with the duration that we're going to be out there, and our budget is aligned with that, we say we're going to be there for 24 months. We estimate that it's going to cost X number of people in these trailers with this equipment. All of that rolls up to a cost. But if it takes a month or 2 or 3 months longer, those costs haven't been accounted for, and those become overruns. Simultaneously, it's not just the overrun that matters, right? When you're building an asset for an owner, that owner is doing it for a reason. They're not just, usually they're, especially in commercial, they're doing it for some sort of financial gain, whether it's, leasing out apartments, or building a manufacturing facility that's going to build some sort of product that can be delivered out to the world. Their finances depend on that too. So when something's late, it affects them equally. So there's losses that can be on the cost side, as well as on the revenue generation side. So it becomes a problem. And then obviously the arguing ensues, and there's additional costs associated with lawyers and consultants. So delays are probably the most costly thing in construction. And finally, this one, I hope everybody believes by the end of this discussion, is that it works. A lot of people aren't 100% there, but coming from a guy who's actually spent time really focusing on building a high quality schedule that's accurate and reasonable, realistic, and then utilizing, an updating process that, factors in what's actually happened. What does that mean? What have we learned from history as it relates to the future? Where are our risk areas? What durations are most critical? Really looking at it that closely, update after update after update, we find that projects get done on time and on budget much more frequently, and there are not very many claims in the process, most likely due to the fact that there's been a lot of communication and collaboration along the way, which is actually something that strengthens the relationships amongst the parties involved. So I view this as one of the most powerful tools in construction, but also probably the most least understood of them all. But if you can merge those two worlds of understanding and utilizing it the way it was designed, you will see much better outcomes in construction. Some common misconceptions that we hear is CPM schedules are for reporting progress. That, you know, when you update the schedule, all of a sudden we know where the project stands. And then it can be used for payment applications or that sort of thing. Another misconception is that it's a waste of time. Like I mentioned, and I'll mention it again and again and again. This, if done properly, is probably the most powerful thing you can do on any construction project. It's just been very highly misunderstood and poorly executed across the board for decades. The last piece, and this is very interesting to me because I come from a world of being a scheduler and being hired to be a scheduler, using this program, being trained in this type of program. It's not that difficult. It doesn't require a human that is called a scheduler to be able to manage it. This program is fairly straightforward if you take the time to understand it. And I hope after today, you will see that this is fairly straightforward. And it's really, you know, as you're building things out, you know, especially project managers and supers there, you know, this is the way your brain works. This program is about getting a bunch of data into the system and understanding what it's telling us. Now, that's not to say that schedulers don't add a lot of value. We do. We do add a lot of value because we've had a lot of practice in this tool, and we know, you know, what the pitfalls are, and, you know, how to actually read a Gantt chart just by looking at it, things that, you know, take a little bit of time and practice to do. But at the end of the day, I believe everybody in construction, if you understand the concepts behind this program and you understand that it actually is a database, very similar to Excel with a user interface that calculates out a plan and some float values for you. It's not as difficult as some people might think. A lot of people call it dark arts. I think it's very straightforward stuff. And I'm going to try my best to get you there. So let's just talk about how it works. First of all, it's literally a list of all the things that need to get done on a job. So that's what your schedule is. I mean, when you go down line by line by line, there is every single one of those things represents something that needs to get done on the job. And now varying levels of detail can exist. An activity could be three days, or it can be 20 days, or it could be 50 days. But in general, each activity represents something that needs to get done. And so you assign a duration to that. So say I want to put drywall up on the 4th floor, and that's an activity that I have a trade contractor working on, and I know it's in a specific area. I have to assign some time. You know, things don't happen immediately, and there's usually a period of time necessary that we estimate at the beginning. That could be accurate or could be wrong, but in general, we want to come up with a duration that we think makes sense. I tend to think coming up with a risk-adjusted duration is a little bit better than one that's like, you know, best case scenario type duration. But nonetheless, you have a list of things that need to get done, and each one takes time, and you need to assign that time. Once you do that, you then need to think about order. And that's done through what are called the relationships or logic ties or predecessor successors. You are establishing that things can't all happen at once. They have to happen in some specific order. Some of these things are based on the fact that you just can't until that thing is done. Or they're also based on preferences on how you want to be moving your crews around a specific site. So there is order in all these things. You don't have unlimited resources every single day. You don't always have the ability to put in one thing while you're putting in another. For instance, you can't put on level 2 concrete without level 1, or you can't put a roof on a building without a structure. You know, there's things that you just cannot do. And then there's preferences of what order of operations do we want to follow amongst the trades going through a specific area, or what sort of crews do we want to move from area to area to area for each specific trade. Those are things that you need to lay out in the schedule, using the predecessors and successors, saying a predecessor being something that happens before, a successor being something that can happen after. Once you have those three things together, activities with durations and relationships, the program does the work. It takes all that information and it lays out what it believes to be an optimal plan based on all this information you provided. A lot of people think it stops right there, that all of a sudden we've laid out everything that we needed to understand in terms of activities that need to get done and the durations that they'll take and the order in which they need to come. And all of a sudden, voila, we've got a plan over time. There's one more very critical piece that I will continue to push on, which makes it so we call it a critical path method scheduling engine, is that's where a priority is calculated. A task gets a number associated to it called float or slack. And if it's got 0 float or slack, that means it has 0 room for delay, and that becomes what's the most critical activity. So that's what, to me, the most powerful thing of this program is, that might be one of the least understood, is that calculation that comes that helps you prioritize based on criticality becomes the most important metric of them all as you make decisions about who's going to be working on what activities that can be going on today. So if an activity has float, what that means is it's got room for delay. But I'll give you an example visually right now. So you can see right here, here's a project that we worked on. I worked on this years ago. It was at a college. It was a dorm. There was 5 buildings. These 5 buildings wrapped around a parking garage. And you can see that there was some order here that, in order to get started, we needed to do the demo and the excavation. And at which point we can start this parking foundation. And once we got done with the parking foundation, which was in the middle of the site, we can start putting up the foundations around all these other activities. And then once we got those foundations done, each building had its ability to put in your framing and enclosure. And you can see that it's a little staggered. So we started putting in order here. But there's an important thing that we need to be able to see. And that is, what is our most important path at any given point in time? And that's what I call our critical path. So there is one path that extends from the beginning of the job to the end of the job, such that anything on that path, if it's delayed, it delays the end date of the job. So for instance, if this parking foundation was delayed 1 month, all of a sudden everything that happens would get pushed out a month, and that end date would push out a month. Now there are areas in here that are not critical, and that's good to know. For instance, site work. Look at this. Once they got done with demo and excavation and they started putting in the parking foundations, they could technically start their site work and finishes, but they actually had close to a year to get it done, about 10 months to get it done. So if this didn't happen for 3 months, or if it didn't happen for 6 months, it could still happen and not delay the end date of the job, because it's got what's called float. It's got a lot of room for delay. Similarly, if you kind of read between the lines here, this particular project had 2 streams of things going on. You can see buildings C, A, B, and D were sort of going in a specific order. They had a crew going from building C to building A to building D. And then they had a crew, framers, going from building C to building A to building D. But at the same time, there was a second crew that was working on E and F. And once they got those foundations done, those framers could move from building E to F. So they had 2 crews going, except for with one of those crews, they had room for delay. It was not critical. So if it ever came down to it at any given point in time where not enough resources showed up, I would know something. I would know that while we were doing foundations, if I didn't get enough concrete in that day, or if I didn't have enough materials, if I didn't have enough equipment, or if we didn't have enough resources working on the job, or if an RFI came in or a change order came in, there's one series of activities that's more important than the other, because the other one actually has room for delay. So if and when order came in, or if and when I only had half the guys show up that were pouring concrete, I would put them on the more critical activity to manage to that end date. And that is why this tool is so powerful, because it gives you that ability to see it. Like I said, if we go back, we go back and don't see that critical path, and we're just looking at these things on a page, which, by the way, it's more like 50 to 100 pages when you're actually printing out a Gantt chart. If you didn't see that value, if you didn't see that critical path, if you didn't understand it, you would not know exactly the right place to put the people. You might even assume that since there's more work to be done over here, it's probably the more critical path. But at the end of the day, this was our longest path. This is where the resources need to be. This is our focus areas if and when challenges came. If and when, it rained, we need to work the weekend on that other activity, because it's just that much more important. So that is really, to me, a very powerful piece to this. But it comes with a responsibility. One thing that I'll point out, like I mentioned before, most projects, most schedules, if they have missing logic, or if they're not, if there's too many constraints, or if the durations are too long, there's all these little things that you can do that would ultimately create a critical path that was not the true critical path. So say, for instance, the durations were incorrect on these activities and these activities. These were actually much bigger buildings, but that wasn't reflected in the plan, such that the real critical path was through these buildings, yet we saw it being in this area and we were managing to that because that's what the schedule said. Then we would ultimately be delaying the job without knowing it. So the most important rule that comes with CPM scheduling is that all the logic needs to be complete, it needs to be accurate, estimated durations need to be close, and then the series of best practices that we will be talking about next week need to be there. And this requires brutal honesty. This requires strict attention to detail. It requires very good understanding of what are all the best practices in creating a schedule, a high quality schedule. Or else the process is going to cause more problems than help at the end of the day. It'd probably be easier and less damaging if you have a broken schedule and you're following it. It'd probably be less damaging not to even look at it, because it's misleading you and it's going to cause confusion and it's going to cause arguments. So if and when you're going to use a program like a CPM scheduling engine, and most companies do, it needs to be nearly perfect and factor in all of these things that we talk about to be useful. But once you get it there and you start using that as our roadmap and trusting it and believing in it and following it and it's accurate, that's when you start to see things change. That's when you start to see, number one, projects get done on time, on budget. Number two, when delays happen, you know what the delay is, what it's being caused by, what the future ramifications are. And most importantly, you can come up with sound mitigation strategies that are actually going to work, something that you can leverage using that scheduled data. So that's really, to me, very important that everybody understands is, this program does work, but it requires near perfection, which requires a lot of understanding, requires a lot of honesty, paying attention, strict attention to detail, like double, triple checking everything. You understanding, what missing logic means, and if we don't have enough crew logic in there, if the total float values are off, if the critical path is off, and you're following this program and it's broken, well, what's going to end up happening is a project that ends late and over budget and a lot of finger pointing, and that's really where they end up in court. So that's really what we want to teach throughout the next few weeks is how do you not end up there? How do we get so good at this that every single one of our schedules is useful enough to understand and manage effectively with? We'll start with the key terms. Like I mentioned, this is a series of activities with logic extended over a calendar. You can see right here, this is our calendar right across the top. This shows all of our activities happening over the calendar. Every activity has a unique identifier. Without that unique identifier, you couldn't assign the logic. And you can see right here with our predecessors and our successors, we are identifying with a given activity what comes before it and what comes after it. We give it a description so we know what we're talking about. This program isn't actually reading these words. This program doesn't understand all it knows how to do is math. But you have to guide it with the words in which you want to call an activity and some sort of structure in which you want to prioritize these activities, what sort of order you're putting those activities in. And you do that with logic. So you give it a name, you give it a duration, you give it a logic, and then all of a sudden it produces this thing on the right. You can see it will tell you even visibly what is my critical path. A lot of times I meet with people that never even turned on the little identifier of the critical path. And they're not necessarily always looking at total float, but you can see right here where it says 0 days of float, those activities are red. That means we have 0 days of delay. And then there's activities that are blue. And this is in Microsoft Project. Primavera is similar. It's, green and red over a calendar, but a series of activities with durations, with some sort of order imposed, and the program does the work. It tells you what things can happen, when's the soonest something could happen, and what sort of room for delay does it have. And if it's red, that means it's got no room for delay. But it is a 3-step process. It's adding activities, giving it a name, it's giving it a duration, and then it's assigning logic. That is what the user needs to do. That is at the minimum what the user needs to do. The next thing that happens is and it is like Excel, right? So just think about this. I have just really cut off the half that doesn't look like Excel. It's a user interface that actually prints out from the program. But this part on the left-hand side, I mean, even in Microsoft Project, the backbone is Excel. It's a database. You list an activity, you give it a duration, you give it some sort of predecessor or successor, some sort of order. That is the user's input. And what it does with that is it creates a plan. So, I mean, I think one of the better values here with this program is the fact that it will take that data that you give it based on your view of how something should be constructed, and then it will produce this plan over a calendar, and it will calculate these total slack as well as criticality. So it does produce for you these start dates. It does produce for you the finish dates. It does produce for you the total float or the slack. And that's very important to note because a lot of times I've seen people try to put their own start dates and finish dates, things that they, will say are going to start in 8 months from now, and they'll put constraints everywhere, and they'll, basically forecast themselves when something should start instead of listing all the little things that need to happen to get to that point via all the predecessors, all the logic, all the different activities that are required to get you to that point where that activity can start. That's what this program is doing for you, number one. It's giving you those start dates, finish dates, and that total float calculation. And number two, it puts it over a very easy way for you to see it so that you can look at it. You can look at what's going on in the next month. And it does give you some sort of order of operations. And it also does highlight for you those things that are most critical towards managing to an end date. And that's what the value of the CPM engine is being able to do that instantly. So I'll say it very many times for the people who may not have grasped it, but what is float and slack? Again, this is I would say the game changer of this system is the fact that it produces this calculation for you. It's the number of days an activity can be delayed before it impacts the end date of a project. Again, that number is basically a calculation that says, for instance, this activity right here, owner stone selection, right here. It says, if it doesn't start on 7/28, it has actually up to 14 days to be late before it actually takes over what we call our critical path. So if you get it done 7 days later than planned, that's still not going to have an effect on your end date. But once all that float is consumed, if you push things off because you don't have resources or you don't have information, there is a threshold of time that you have to do that. And the ones with the higher amounts of float have higher room for delay, meaning you can push them out further and further and further. Whereas activities with 0 days or 1 day or 2 day or 3 day, they start ones that you really don't want to delay. You don't want to get done in more time than you agreed it should take. You don't want to start it late. So this just gives you that ability to understand, with all the little things moving on, all the things going around on this site, there are some activities that are very, very, very important to get done timely. And then there's some that are not. And that's really the crux of it all, is understanding where each activity stands in that regard. Why is it relevant? Well, again, it enables teams to prioritize. With all the little things that are happening, with all the resource constraints that typically exist, or when, supply chain issues are happening, you will know which ones are going to cause big problems and which ones are not. And that will enable you to make better decisions on, for instance, if something is going to be extremely late delivered and there's nothing you can do about it and it's a critical path activity, well, we've got to start thinking about how do we manage with that reality in mind. It could be a discussion. It could be completely resequencing the work. For instance, a certain bit of structural steel is not going to get there on one side of the building, and you can start on the other side of the building instead. These are things that until it comes to light and for sure it's going to be a problem, things that you can do with that is come up with mitigation strategies that actually work. And if you didn't know this information, the mitigation strategies or the planning process would essentially fall apart because you'd be guessing. So that's why this is so important. You can see visually that there's some float. You can see visually what the critical path is as well. And that's what these programs are really designed to highlight for you. So if you're sitting there on a site and you're looking at a schedule, you can see exactly what's important to get done and what are those series of activities that need to get done. And you could even look at what trades need to be where and when based on that so that you can start having those discussions ahead of time. But that's really, to me, the value of this program that transcends just printing out a schedule over a calendar. There's a couple more features that are built in that I haven't talked about. Number one, there's organizational structures or work breakdown structures. So in addition to having these calculations of start dates, finish dates, percent completes, and all of that ultimately result in a total float metric, there's also some sort of organization, because some of these schedules can be large. The largest schedule I've ever seen was 264,000 activities on the Big Dig up in Massachusetts. Generally speaking, schedules are anywhere between, we'll call it a few hundred and a few thousand activities, but even a few thousand activities can become very confusing. For instance, if you don't have an organizational structure, all you really can do is sort by start date. And that can show you, in this case, this is a multi-floor building. Different things are happening at different points in time. For instance, like install pipe insulation on the 5th floor can be happening, and install curtain wall on the 7th floor and pour the 11th floor. All of those things can be happening, but that doesn't really align with how we view the structure and how our brains are operating and sort of compartmentalizing the building or the structure that you're working on. So building a WBS structure that sort of aligns with how you compartmentalize a building or a structure. For instance, a 10-story building, you might want to look at it by trade or by location or by floor or all of the above. So you can, in each of these or any of these programs, give what's called an activity code or some sort of WBS structure that aligns with how you would want to bucket these activities into groups. So it's a little bit more understandable and in alignment with how you would be looking at the project. For instance, in this case, you can see that they've broken out, design, pre-con, permits, and then getting into construction, looking at various aspects of that, starting with foundation, getting into structure, and then ultimately getting into, MEPs and interiors, but breaking it out by floor. You can start to see that this view that's very confusing starts to look a lot more pleasing to the eyes when you can, roll it up and look at it at a higher level in some specific order that really aligns with how you would organize the structure of the building in your own mind. And yes, as you can see, when you open up each section, you can see a little bit more cleaner waterfall. When you roll that up, you can start to see the period of time that all happened. So to me, it's a very important part to have a very good organizational structure. Again, we talk about this program, these scheduling programs, being a tool for you to essentially take your plan out of your head, put it into something that's going to tell you a lot of things that you just can't know in your head, and then also give you some good information on prioritization. And then when you organize it as such, you can start to really picture and understand a job at a higher level. This starts to become a better communication tool as you're communicating to your subs, as you're communicating to your owners, whoever you're trying to communicate a plan to. an organizational structure is only going to make it that much easier to digest. And then finally, we've got calendars. So the last piece, and we didn't talk about it back up here because we were talking about durations, but the number one or two thing that you need to remember is that the whole goal of a scheduling program is to really mirror the world around you in a way in which things are going to be built over periods of time that you believe it's going to take. And if you didn't factor in weekends, if you didn't factor in holidays, then the program itself would be telling you that you can work on days you can't. If those are critical path activities, then it's basically saying you've got a delay built into your plan. There's certain things that you can put in calendars like, weather days, anticipated weather days. You can be working 4-day weeks, 5-day weeks, 6-day weeks, 7-day weeks. You can also be blocking out, entire periods of time that you just can't work. For instance, a lot of these calendars, you'll have a concrete calendar in, say, Minneapolis, where it's snowing about 2 feet right now, where they're not going to do concrete work in the winter, and that concrete work better get done by the end of November, or it can't start again until March. So there's calendars that you can put in there such that if and when an activity pushes into a time frame that it can't work, the schedule will update realistically. For instance, if you were in the middle of a structure and then all of a sudden all concrete work had to stop for the entire winter, if you were able to get it all done beforehand, your project wouldn't suffer a 3-month delay. But once those activities pushed into that calendar, it pushed it out until March, so that you now know that you've got a problem on your hands, and you either have to come up with some way to get this work done now, or we're going to have to come up with a way to minimize the cost exposure due to those impacts. So calendars become a very important piece to the equation as well. It's useful in factoring in the holidays and the weekends. You can do 5-day, 6-day, 7-day weeks. Every activity can be assigned to a different calendar. It's not like you just have one calendar sitting in the program. Every one of these activities may have something different associated with it. Some of them may be weather sensitive. Some of them may not be. Some of them may be, with a contractor that only works 4 days a week, or some of them may be activities that you want to put on a 6-day week because we've got to accelerate. So, you don't have to assign one calendar to all activities, although you can, but every activity can be assigned a different calendar, and the program will calculate for you based on those calendars. But that pretty much explains CPM scheduling in a nutshell. I hope this was educational for some. I know many people probably on here, this was a lot. This is a lot of stuff that you already know about. But nonetheless, now that we're here, we can move forward into what we're going to discuss next week. And that's, okay, great. This program's supposed to work. It tells me things about order over time. I set it up the right way. It starts to tell me things I need to know. There are organizational capabilities. You can factor in any sort of calendar constraints as well. That's awesome. But like I said, if you're not following a series of best practices, if you're not understanding what the risks are with certain methodologies of scheduling that aren't very favorable, for instance, having a ton of long activities with like 90-day durations representing entire floors of work is just too much work to actually in your brain calculate progress on, especially if it's, say, an entire floor of interior works, which some cases people do that. Instead of breaking it out per trade and putting order amongst those trades, those things can result in a schedule that's very easy to mismanage, which completely renders the program useless. So we're going to talk about a process, solid plan. Like, what is that process? Now we're also going to talk about quality. What are the things you need to remember to ensure that your schedule is of the highest quality to be utilized as a management tool. So it's telling you the right things. So as the critical path turns a certain color, you can trust it so that you can make decisions based on what it's telling you. And then, with all these programs, there's risks in being able to actually build that schedule out right. We'll talk about those as well. And that's really what's up next for next week. If I can, I will answer a couple questions now because it looks like I've got about 5 more minutes. Negative float. First of all, will we be receiving a copy of this presentation? I believe so. Yes, we will, as will there be a recording. Can you please elaborate on the resulted period for which the contractor is entitled for a compensable extension of time and the best practices to assess monetary value accordingly? Okay. That'll be something that we cover in a few weeks from now when we talk about delay analysis. But real quick, when a contractor has something that happens that impacts the critical path of the job to a point where the end date is pushed out, and it's provable that it occurred and it was a critical path delay that they did not cause, then ultimately they are usually allowed an extension of time. Now, if it's something that they did cause, they are not. That extension of time is compensable if it's, say, a permit issue was proven to be critical and it did push the end date out, or there was a critical path activity like, putting up the structure, and then all of a sudden a big design change came in that they had no control over and they needed to wait. However, and that was on the critical path. It needs to be proven it was critical because that is the only path that can delay a job, as we discussed, which comes with a lot of challenges because a lot of schedules are arguable at best and the critical paths are arguable at best. But once you can prove that it was a critical path delay and it was not anything that you caused as a contractor, then you are allowed an extension of time and it is compensable. And the amount, the dollars in which you would charge for that are number one, how much did it cost you as the GCCM to have those people there and all that equipment out there and all those materials and trailers and trucks and all that? What were your general conditions? But then there's also additional inefficiency costs that can happen to the subs, that if you can prove that that impacted the subs and it cost them more money as well, that can be rolled into a claim as well. Let's see. Have you found a way to hold material equipment suppliers accountable for delayed materials or equipment that affect the project schedule? I think that that's really on a case-by-case basis. If and when, the contracts between the contractor and the owner, and the contractors generally signing up for some risk. But these days with the supply chain issues, I think contracts can change slightly because it's sort of, very difficult to forecast any sort of supply chain issues. So there could be verbiage in a contract that could alleviate the damages to the contractor for those issues. But at the same time, you may have a contract with your material vendor that basically, puts them liable for damages if you do actually negotiate that out. Another question was, what explanation could have a negative float? Do I have for negative float? Negative float only happens when you put a finish constraint in a schedule. So for instance, if you say that the end date of the entire schedule needs to happen on a certain day, let's just make it up and say the end of this job will be on December 31st. And we've got our baseline schedule we created today. We go update that schedule and there was critical path delay to the point where the end date pushed out past December 31st. Now the end date's projecting January 5th. Well, float is now negative because of it, because we're holding to a date that it's calculating from, and we are 5 days behind that date. Now, I am not a huge fan of finish constraints. I think that finish constraints result in confusion because the critical path is the longest path, the one and only path that's pushing to the end date. And once you start having multiple interim milestones with finish constraints, it starts to mask the true critical path of the job. So I will be speaking about that next week in quality, but generally speaking, a lot of people use it to know how far behind they are. But what's at risk is it starts to create many red activities that can be misunderstood as truly critically driving the end date, whereas they may just be red because they're negative float for some interim milestone that will not actually result in an extension of time or additional damages related to that delay to the end date of the job. But I think that's it, guys. It's 1 o'clock. I appreciate the time today. Again, we will be following up with answers to all the questions that we receive. And I look forward to seeing you guys next week. And again, if you have additional people that you'd like to bring to this, great. If you would like to be sharing this video, I believe we will be sending out the video. You can share it amongst your teams. We use this training course to train lots of different people, whether it's project managers, supers, whether it's I guess executives, whether it's anybody who wants to understand scheduling, the point of scheduling, how to talk schedule, how to effectively manage schedule, how to understand analytics benefits from this course. So we're happy to, anybody you want to bring them all. Thank you so much, and hope you have a wonderful rest of the day, wonderful week, and we'll see you next week.